Hello, good afternoon students. In the last class we were discussed here some of the most interesting concepts, that is photoelectric effect and as well as that spectrum also. So today in this session we are going to continue here some of the parts which is left over yesterday, that is absorption spectrum. Okay, so we will discuss that particular part here. So let us continue this particular session with here absorption spectrum. Absorption spectrum. Yes guys, so since we have know already that is spectrum, so spectrum is nothing but any particular radiation is directly passed through that particular prism and that a particular pattern that has been obtained on that photographic plate or photographic film, that we can call it as here spectrum. So in this particular spectrum we already classified into two particular types will be, one will be emission absorption spectrum and so that is generally absorption spectrum, and emission spectrum can be classified into three particular types. One will be continuous emission spectrum and band emission spectrum and line emission spectrum, and absorption spectrum can be classified into two types. One will be line particular absorption spectrum and band absorption spectrum. So today in this session we are going to discuss here a absorption spectrum, guys. So then what is meant by here absorption spectrum? What is mean by absorption spectrum? The name itself indicating here absorption, isn't it? So absorption is nothing but here, suppose we have a white light, that white light supposed to be passes through a particular prism and that particular radiation have been obtained on that photographic plate, that we can call to be as in here a absorption spectrum here. Means the main criteria for that absorption spectrum, it could be here we have to take on a particular gas or a vapors of a chemical substance or a solution. So among these three particular component we have to take any one of that particular thing and we have to passes a particular radiations through this particular a substance, either it may be a gas or either it may be a vapors of a solution or either it may be a any particular solution here. Okay, so if you want to pass a particular radiation through these particular compound, means a radiation has to be obtained. That radiation, if you could find out in that, analyze in that spectroscopic with a spectroscope, then a pattern has been obtained. So that pattern which consists of in here a dark line, guys. Okay, that we can call to be as in here absorption spectrum. Okay, very simple. We have a white light, that white light has to be passed through a generally gas. Okay, we have three substances, among those three I am going to take in here gas. Okay, a white light have to be passed through a particular gas. Okay, then that a radiation that have been obtained on that photographic film, that can be analyzed by spectroscope, and that pattern what could be obtained there over, which contains a dark lines, guys, which contains dark line, that we can call to be as in here absorption spectrum. Absorption spectrum. So let's write this particular absorption spectrum here. Yes guys, so when white light is passed through a gas or vapors of chemical compound or a chemical substance or a solution and the radiation is analyzed by spectroscope and the pattern is obtained on a screen which consists of or which contains a dark line, that we can call to be as here absorption spectrum. Okay, so we have a white light. That white light is made to pass through that particular gas or a solution or a vapors of chemical substance. Then that radiation is going to be absorbed, guys. So that radiation have been analyzed by one particular spectroscope. Then that a pattern has to be obtained at a photographic film or a screen. Okay, that particular pattern or that particular spectrum which consists of a dark line, that we can call to as here spectrum. So the thing is that here the pattern or spectrum here, so pattern is nothing but here spectrum, guys, that's it. Okay, so this is all about here absorption spectrum. Suppose, so I just tell you that absorption spectrum finally you know that classified into two types, as we know that already. There is a line absorption spectrum and so band absorption spectrum. So what is mean by then line and as well as that band absorption spectrum, we will discuss one by one right now here. So I'll just have to go with that very first, that is line absorption spectrum. Line absorption spectrum. So guys, line absorption spectrum is nothing but a white light is passed through a particular atomic gas. Okay, a white light that has to be passed through a particular atomic gas, then the pattern is obtained, that then we can call it as here a particular line absorption spectrum. Okay, so very simple, guys. A white light we are going to passing over that here a particular atomic gas, then the pattern is obtained on the photographic film, then we can call it as here, that we can call it as here line absorption spectrum. Very simple, right? So write down, guys. So line absorption spectrum is nothing but when a white light is passed through an atomic gas, the pattern is obtained called as an line absorption spectrum. So this is the thing here, line absorption spectrum is nothing but this is the fact. Okay, so then what is meant by here? So band absorption spectrum, very simple. In the case of line absorption spectrum, we are going to use here that particular atomic gas. Okay, atomic gas. But in the case of, suppose we are going to get band means, so the thing is that we are going to subjected here a molecule, that is particular molecular gas. Instead of that atomic gas, we are going to use their molecular gas, then only you could able to get there over a band. Then we can call to as on here a band absorption spectrum. Okay, so the case of line absorption spectrum, the main criteria is to be here, we are going to use there over a atomic gas, guys. Okay, so then we are going to get actually there over a line absorption spectrum. Suppose if you want to get here a band means, we are going to introduce there over a molecular gas, then only we can call to as such kind of pattern, that is a molecular absorption spectrum. So means like band absorption spectrum. So let's write down here molecular, that is band absorption spectrum. Yes, guys, a band absorption spectrum. So band absorption spectrum stands for here the same thing, the same phenomenon is going to be taking place here when a white light is passed through a molecular gas, the pattern which is obtained there over, the pattern is obtained is called band absorption spectrum, band absorption spectrum, that we can call it as here band absorption spectrum. So guys, so this is all about here a spectrum. Okay, so spectrum actually classified into two types. One will be emission spectrum and absorption spectrum, and emission spectrum further have been classified into three types: continuous emission spectrum, line emission spectrum, and band emission spectrum. And here again absorption spectrum have been classified into two types. One will be line absorption spectrum and band absorption spectrum. So this is all about here spectrum concept. So today again the next we will go with that very next concept, that is hydrogen spectrum. Most important guys, which is very important for your examination purpose and as well for your competitive also, and so and at the same time very easy concepts these all are. Okay, so let's discuss that particular concept right now, that is hydrogen spectrum. So we'll see that what what are the main informations we are going to get from that particular concept. So we'll discuss one by one, very much interesting concepts that particular thing. So let's go with that particular concept right now. Okay, that is hydrogen spectrum. Hydrogen spectrum. So yes guys, so hydrogen spectrum, since we have no here spectrum which is a pattern, isn't it? Spectrum which is a pattern that is obtained on that photographic film, that we already know that spectrum. But what is mean by hydrogen spectrum here? What is mean by hydrogen spectrum? See, very simple. Hydrogen spectrum is nothing but, so we have an hydrogen gas. Okay, we have an hydrogen gas. So that hydrogen gas that can emit that radiation. Okay, suppose when hydrogen gas is going to be excited at that particular time, that can emit some sort of radiation. That radiation is made to pass through that prism, and that so the pattern which is obtained on that photographic plate, which contains here a small discrete lines, okay, that we can call to be as in here hydrogen spectrum, isn't it? So this is the scenario here. So whenever that hydrogen gas is to be excited means, so at that particular time a radiation has to be emitted. So those radiation is directly passes through that prism, and that they can form there a small discrete lines over that a photographic film, that we can call to be as in here a hydrogen spectrum. And we that we actually want to know that here experimental, how that actually a hydrogen spectrum is going to be takes place. So their experimental observation also we could know this particular thing as well. Okay, so let's discuss those things. So we will first get into that hydrogen spectrum here. Okay, hydrogen spectrum is a thing, but write down guys, very simple here. Okay, so when hydrogen gas is excited hydrogen gas, whatever it may be. Okay, when hydrogen gas is excited, then which emits radiation, okay, so is passed through a prism, and it could form the small discrete lines over the photographic plate or photographic film or screen. Okay, that we can call to be as in here hydrogen spectrum. See, the small discrete line, sorry, not quantity, that is small discrete line, that we can call to be as in here hydrogen spectrum. Very much important guys here. See, when a hydrogen gas is that excited hydrogen gas supposed to be, that emits some sort of radiation. That radiation is directly passes through that prism, and that on the photographic film a small discrete lines has to be obtained in that pattern, that you can call to be as in here a hydrogen spectrum. Hydrogen spectrum, isn't it? So this is nothing but here hydrogen spectrum. And then so we have to know here their experimental observation, means how does that particular hydrogen spectrum is going to be takes place. See, the thing is that right now we have a hydrogen gas. Since we are studying here hydrogen spectrum, we should taken there over hydrogen gas itself. Okay, that hydrogen gas supposed to be we are taken in the discharge tube, and that can be, for the discharge tube, suppose if we can apply here a high potential difference, okay, a high electrical potential difference supposed to be if we can passes through that particular discharge tube, means so discharge tube which contains here hydrogen gas. Since we are studying here hydrogen spectrum, there must be an hydrogen gas would be there, guys. Okay, so this is the scenario. We have a discharge tube. In the discharge tube hydrogen gas has to be there. Okay, so for that particular discharge tube, suppose if we can apply here a high potential difference, then that what happen, a bright light has to be emitted. A bright light has to be emitted from that particular discharge tube. That bright light we have to directly pass through that particular prism, and that a particularly a beam of radiation has to be obtained on that a photographic film, that we can call to be as in here hydrogen spectrum. Actually this is the what I just told you, this is the way of getting that hydrogen spectrum. Okay, so this is the process. So we are going to we have an here hydrogen spectrum is, so behind on that particular thing, so this phenomenon is going to be takes place. So this is the scenario, guys, isn't it? So let me repeat once again here. We have discharge tube, guys, generally. Okay, discharge tube which consists of an here hydrogen gas, isn't it? So for that particular discharge tube we are supposed to be applying here a high electrical potential difference. Then what happen, from the discharge tube a bright light has to be emitted. That emitted bright light is made to pass through that here prism directly, okay, or passes through the particular prism directly. Then that radiation which is emitted that has to be obtained as that photographic film. So it would be that here a small discrete quantity. So this is the scenario that we can call to be as in here hydrogen spectrum. Okay, so then if you want to explain that a hydrogen spectrum means here, if you want to explain here hydrogen spectrum means we require one certain model here. So based on that particular model, it could possible to giving that explanation for that particular hydrogen spectrum. Okay, then what will be that particular hydrogen atom here? Okay, what will be that particular model here? Okay, so which is that particular model that can be very, that making very easy to understand that here. So hydrogen spectrum. So what is that particular model? So the thing is that that model is nothing but here Bohr's atomic model. Bohr's atomic model. So we will discuss that particular Bohr's atomic model. So with the help of that Bohr's atomic model, so we are going to understand that here a hydrogen spectrum actually how it going to be takes place. So this is the process. What I just told you that is the process, but explanation, if you want to that more explanation means their explanation it could be based on that here a Bohr's atomic model. Then what is that Bohr's atomic model? So what are the postulates are there over in that particular model? We will discuss one by one here. But how that Bohr's atomic model is going to be generated or is going to be created means Bohr's is a scientist. What he actually going to do means, so we have already that is Rutherford atomic model, isn't it? So Rutherford atomic model we have, since we have the Rutherford atomic model and Planck's quantum theory. So what he actually does means he applying a Planck's quantum theory over that Rutherford atomic model, and you just merge those two particular theories and he created his own particular model, that is Bohr's atomic model. So we will see that what are the important stuffs are there over in his particular atomic model. So we will discuss one by one. So let's concentrate, guys. So I am just going to rub this thing. Bohr's atomic model. Bohr's atomic model. Okay, so he actually does here, he just merge here or he just applying a Planck's quantum theory to that Rutherford's atomic model. Then he created his own theory called as in here Bohr's atomic model. Okay, but according to him, so what particular his model which consists here? So what are the things his his particular model have the stuff here. Very first he give that very first postulates. See, as we know that here atom which consists of a nucleus at the center, and most of the mass of the atom is going to be concentrated at center, isn't it? So we have an atom, okay. So at the center what will be there? Nucleus, okay. At the center nucleus has to be there, and that most of the mass of the atom has been concentrated at center only, okay. This is the very first assumption or very first postulates have been given by here Bohrs, okay. So let's write guys here the very first atomic model. So the thing is that according to him atom which consists of a nucleus and most of the mass of the atom is concentrated at center. Most of the mass of the atom is concentrated at center. So this is the very first postulates has been given by here Bohrs, okay. And then second postulates, what he actually going to tell us that, okay. So tells us that the thing is that, see, since we have an atom and so that nucleus has to be there at center, so around that particular nucleus what will be there? Electron has to be there, right? Okay. So the electron, according to him, the second postulates would be like that: the electron that has to be revolve around the nucleus in a selected or in a particular circular path, okay, in a particular circular path called to be as here orbit, isn't it? The electron that has to be revolve around the nucleus in a certain circular path, called to be as here orbit, okay. But the thing is that since electron that has to be revolving, their movement it should be here rotation, isn't it? Then any charge particle is going to be rotating, means it should have one particular character, that it could be here angular momentum, isn't it? Hence that, so such that what happen, so that electron is being a negatively charged particle and that going to be revolve around the nucleus, hence that this particular electron having one particular character, that is angular momentum, their angular momentum which is equal to, so there you know that h by 2 pi. So their angular momentum is going to be equal to here h by 2 pi, which is an integral multiple guys, okay. So h by 2 pi. So this is the second particular postulates here. You just focus on these things. So second postulates would be like that: an electron revolving around the nucleus in a certain circular path, called orbit, called to be as here orbit. Orbit is nothing but here a circular path where electron has to be revolving, okay. So this is an here a orbit. So such that since here electron which is revolving, which is rotating, is being a charged particle that has to be rotating, means it should have one particular character, that is angular momentum. At the same time, any charged particle that have been moving along with that straight line, means it should have an here a linear momentum. We should know that a total contrast between that angular and the linear momentum here. So the thing is that, see, so since that is revolving around that nucleus, that should have an angular momentum such that the angular momentum of an electron is equal to nh by 2 pi. N is nothing but here integer. Suppose if you want to express this particular statement in terms of mathematically, means that is, okay, angular momentum guys, this angular momentum is nothing but here mvr, okay. So which is equal to nh h by 2 pi. So here m is nothing but mass of electron, v is nothing but here velocity of electron, r is nothing but here radius of an orbit, so radius of an orbit, and so n is the limit here integer or a whole number. Okay, 1 2 3 4 like that. Okay. So this is the thing here. So the second postulate he could made here, that is an electron revolving around the nucleus, revolving around the nucleus in a certain circular path called to be as an orbit. So since it is rotating in a circular path, hence it could have an angular momentum. Their angular momentum which is equal to here nh by 2 pi guys. So this is the thing actually. Okay. So the second postulates. So let's concentrate the third. What is the third postulates he has given there? Yes. See, observe here, the electron that has to be revolved in a circular path, isn't it? But third postulates according to him, as long as electron revolving in a circular path, as long as electron means as long as this particular electron which is revolving in this particular circular path, it does not emit energy. Okay. So the thing is that, which means that the energy of an electron, it would be constant at particular orbit. Okay, isn't it? So then you should have a doubt here. Okay, you should got a doubt here. What that particular doubt? So then the energy of an electron, it must be constant, means then there is no variation in that energy of electron at all. Okay, obviously there could be energy have been changes in that in an electron, but not in an orbit. Suppose if it has made an excitation or a, so that particular electron, so going to transition from one particular orbit to another particular orbiter means then only their particular energy have been changes. Okay, so that's also next postulates he'll explain there over. So but the thing is that the third postulates would be here, as long as electron which is revolving around that nucleus, energy does not be emitted. Okay, so that electron which does not emit energy, which means that energy of an electron which is a constant at particular orbit. This is the third postulate. Write down, as long as electron revolving around the, or as long as electron revolving in a particular path, in a circular path, it does not emits energy. Which is the third postulate guys. Fourth one. See, so from the third postulates we came to know that energy of electron which is to be constant at particular orbit. Okay, but fourth postulates could be like that. Suppose I just have drawn one more orbit here. Okay, see, let us taken this is first orbit, their energy E1, and second orbit their energy E2, and third means E3, 4, E4, just like that, n numbers. Okay, suppose since we already got to know here, that is energy of an electron in a particular orbit is going to be constant, but energy of electron when is going to be changes, we should know that particular thing. Obviously the thing is that electron's energy is going to be changes when it actually going to make a transition. Okay, when that made a transition from one particular state to another particular state, or one particular energy level to another particular energy level, then only their energy is going to be changes, either it may be in absorption or in case emission. But totally what happened, that energy is going to be changes of that particular electron. Okay, see that, suppose electron which absorbs or emits. Okay, but when that particular electron which absorbs the energy, or when that particular electron which emits energy, we should know that particular thing. Suppose consider electron which is present in that first orbit. this is the first orbit, which is an second orbit. Suppose this particular electron jumps from lower energy level to higher energy level, lower energy level to higher energy level, which absorbs energy, at the same time, whereas electron that has to be jumps from higher energy level to lower energy level, then which emits energy. So concentrate guys here. Electron made a transition from or jumps from lower energy level to higher energy level, so energy would be absorbed. At the same time, from higher energy level to lower energy level, electrons which is jumping means what happened? The energies must be emitted. Okay, so this is the thing here. We should know this particular thing. Okay, so write down fourth particular postulates. The energy, or when an electron jumps from lower energy level to higher energy level, energy is absorbed, whereas electrons jumps from higher energy level to lower energy level, what happened? Energy is emitted. Okay. So this is the fourth postulates has been given by here Bohrs. Whenever that we have that n number of energy levels here. Suppose if electrons made a transition from or excited or jumps from a lower energy level to higher energy level means energy which is absorbed. Okay, at the same time that particular electron which is jumps from higher energy level to lower energy level means energy is emitted. Okay, this is the thing guys. So this is the fourth postulates. And fifth one, so he could made here most important this particular thing here. See, whether electrons energy is absorbed or emitted. Okay, so our energy is absorbed or emitted by that particular electron, that has to be equal to that difference in that energies of the two orbit. That particular energy that has to be equal to difference in that energies of the two particular orbit. So consider here, suppose I just tell you, I'll just show you here. We have an atom. So this is the first orbit, their energy will be E1, and this is the second orbit, their energy will be E2. Suppose this particular electron that has to be jumps from first orbit to second orbit or second orbit to first orbit. So there must be energy which is absorbed when jumps from first orbit to second orbit. Energy has to be emitted when jumps from second orbit to first orbit. But the thing is that with the irrespective of their particular transition, the energy of that particular electron, either it may be released or an absorbed, that particular energy which is equal to the energy difference between these two particular orbit. The energy difference between these two particular orbit, isn't it? So the thing is that suppose if you want to, if electrons had made a transition from first orbit to second orbit means their particular energy difference will be E2 minus E1, which equals to delta E, and the delta E which equals here energy of quanta of radiation, that is h nu. This is the fifth postulates and ultimate, and then so a last postulate here. See, is mean to say is that if an electron which is absorbing energy or an emitting energy, okay, with the irrespective of those particular thing, their particular energy of an electron which is always been equal to that, so the energy difference between those two particular orbit, so from their transition have made from that particular orbit to this correspond, so from where to where that particular electron have made a transition there. Okay, suppose if electron made a transition from first orbit to second orbit or second orbit to first orbit, means that that particular energy of that particular electron which is equal to energy difference between those two particular orbit. Or suppose if electron made a transition from first orbit to third orbit, okay, then that energy difference is must be here E3 minus E1. Isn't it? So this is the scenario, guys. So this is the thing. So this is that particular fifth postulates has been given by Bohrs. So it will be energy is released or absorbed by an electron is equal to energy difference between the two orbit. Okay, so that suppose if you want to mathematically express, means that is delta E which equals to E2 minus E1 which is equal to h nu. Okay, 2 orbit and which is equal to energy difference between the two orbit, and also which is equal to energy of quanta of radiation. Yes, so this is the thing here. Okay, so this is all about here that Bohr's atomic model. So with the help of this particular atomic model, we are going to explaining here a hydrogen spectrum. Okay, so this is one of the major milestone in that hydrogen spectrum, guys. So because without this Bohr's atomic model, so we couldn't get that actual explanation for that hydrogen spectrum. So in order to hydrogen spectrum properly, then we should have a Bohr's atomic model. Okay, so with the help of that particular Bohr's atomic model, so we are going to learn that how that hydrogen spectrum, so what are the things are going on in that particular hydrogen spectrum. So we will discuss that particular thing. So generally what happened, suppose in order to understand that hydrogen spectrum, how that electrons transition, how that electrons made their over transition, so from one particular state to another particular state, or lower level to higher level, so how these things are going on there, so that can be explained based on that here a Bohr's atomic model. So actually what happened there, so if you take a discharge tube, means that explanation could be like that. Okay, so we have a discharge tube. So in the discharge tube we have an hydrogen molecule. Suppose if you pass through or suppose if you can apply a high electrical potential difference, means that hydrogen molecule could absorb that particular energy and breaks down and get converted into hydrogen atom. Okay, so we have a discharge tube. In the discharge tube, hydrogen molecules are going to be there. So when we are going to apply here a high potential difference of electrical energy, then that particular hydrogen molecule could absorb that particular energy and break down into and get converted into atoms. Okay, molecules to atoms. And then what happen next, you just concentrate here. See, an electron which is present in the different hydrogen atoms, so could absorb different amount of energy and get excited to different higher energy level. And those electron will not be remain on that particular state. Instead, they fallen back to that a lower energy level. While coming back to that lower energy level, they could emit some sort of radiations having different energies. This is the scenario. Suppose if an electrons that has to be jumps from higher energy level to that a first lower energy level, they could emit here, or they can absorb, or they can produce here a UV radiation. They could produce here UV radiation that can be caused for an here a Lyman series. So Lyman, he was the scientist who could observe that spectral lines in that particular radiation in this particular hydrogen spectrum. In that hydrogen spectrum, that some particular lines has to be obtained in that UV region. So hence their particular spectral lines can be recognized by their name. Okay, so number of scientists have came there over. Okay, so based on their particular observation, they could recognize by their names to that particular spectral lines. Okay, so this is the scenario here. If an electron jumps from a higher energy level to first lower energy level, they could, you know, that they can produce here ultraviolet radiations, and it could be caused for an here Lyman series. At the same time, if an electron made a jumps from higher energy level to second lower energy level, they can produce us visible radiation. They can produce us visible radiation, and which is caused for an here a Balmer series. At the same time, electron jumps from higher energy level to third, fourth and fifth lower energy levels, and they can produce us IR radiations, right? They can produce us here IR radiations, means infrared radiations. Okay, and respectively they could be producers, or they can be caused for here a bracket and Paschen and P-Fund series. Bracket, Paschen and P-Fund series. So this is the scenario, and their particular explanation that can be shown by diagram, with a diagram. Okay, in the next class I am just going to have that particular session. Okay, so thank you one and all guys.